We're going to look at how to convert fractions to base 60. So basically what we're trying to do is find the decimal version of the fraction, meaning we need to write the fraction as sums of fractions with denominators that are powers of 60. So let's look at the example 12 over 80. We want 12 over 80 to be a fraction with a 60 in the denominator. So therefore, 12 over 80 is x over 60. If I multiply both sides by 60, I get x is 60 times 12 over 80. So it's 720 over 80, which is 72 over 8, or 9. So basically, we look at the decimal expansion for our base 60 number, and we see that we have 9 in the 1 over 60 column. So we write this number in base 60 either using the bracket notation, where the semicolon means the decimal point, or if we just use the decimal notation, we would just write it as 0.9. Let's do a more complicated example to see what happens if it doesn't go evenly. I'm going to write 7 over 45 in base 60. I'm going to repeat the process. 7 over 45 is x over 60, and so x is therefore 7 over 45 times 60, which is 420 over 45, which is 9.33. So let's see what we have so far. So 7 over 45 is 9.33 over 60. Well, I don't want that 0.33. That's not a valid base 60 digit. So I'm going to break it up as 9 over 60 plus 0.33 over 60. So that means that the 9 goes in this spot, and now we're trying to figure out what goes in the 1 over 60 squared spot. So far we have 0.33 over 60, but we want it to be something, let's call it y over 60 squared. So if we multiply both sides by 60 squared and simplify it, we get y is equal to 0.33 times 60, which is 20. So let's recap what we have. 7 over 45 is 9.33 over 60, which is 9 over 60 plus 0.33 over 60, which is 9 over 60 plus 20 over 60 squared. And so the 9 goes in this column, the 20 goes in this column, and of course we don't have any integer part, and that's it.